So we're
We
going
can
to start
start
off
off with a pair of linear equations.
3x minus, or 5x minus 6y equals minus 4. And the second equation is 3x plus 2y. Come on, find the y, not another 7, please. Equals minus 8. All right. Now, in this case, what we're going to have is we can solve this easily. Okay. So let's go through the stages. We look at this and we say, okay, what are we going to use? We're going to use the substitution method in this one, and we're going to do another problem in a bit using a different method. Okay, so the substitution method is going to be, we'll solve one of the equations for y. Okay, so we're going to pick equation 2. Equation 2 is 3x plus 2y equals minus 8. And we're going to rearrange it to 2y equals minus 8 minus 5x. Okay. So we just, all I did, or minus 3x. All I did was subtract 3x from each side of the equation. So now we have that. So here is an example where it's a little more complicated. Okay? Because now we're going to have y is going to equal a fraction. Minus, oops, back up, minus 8 minus 3x and this is all going to be a fraction, so I'm going to underline it. Over 2. Now, please excuse me. Word absolutely hates a small letter at the beginning of a sentence. So I'm going to fix it. Okay, so now we have a fraction. And that's okay, because what we're going to do now is structure our next equation. We're going to take that and substitute it into the first one. And now we'll get 5x minus 6. And we're going to have to imagine we've got this parenthesis here, times minus 8 minus 3x. Okay. And we'll put an underline under that, using a rather crude method of doing fractions in Word. Okay. And this is all divided by 2. Okay, so now we're going to solve for x. 5x rather. Yeah, and that all equals minus 4. Okay. Right? So first thing we're going to do is divide the 2 into the minus 6. We're going to simplify this. We're going to divide that in, and now the equation becomes 5x minus 6 times, or minus 3. Can't get it right, can I? 3 times minus 8 minus 3x Oh, come on. And we'll underline that. And again, and that now equals, we don't have to underline it, do we? No, we've already cleared that. My apologies. I have had the beginning of a horrible cold. So that's my excuse, and I'm going to stick to it. Equals -4. All right.
So now all we have to do is simplify this.
So we have 5x minus 3 times minus 8 is what?
Negative 24.
Positive
24.
Minus times minus. So that's plus 24.
Okay.
Minus 3.
No,
I need to do that.
minus 3 times minus 3 is what? Okay, so now we have plus 9x, right? And that now equals -4. So now we simplify it. Next stage, we combine the like terms. So we've got 5x plus 9x is 14x. Plus 24 equals -4. And now we're going to subtract 24 from both sides, right? Okay. So we now have 14x equals what?
-28.
-28. Very good. Thank you. -28. And therefore, x equals
Two.
-2. 14 minus 28 divided by 14 is -2. Word, you're a pain in the neck sometimes. All right. So now we just take that and substitute it back into, substitute the value for x back into any equation. So I'm going to come over here, and I'm going to substitute it into the second equation, just because we did the first equation a minute ago. So x is -2, right? So we have 3 times -2, right? Plus 2y equals -8, right? So 3 times -2 is what? -6 plus 2y equals -8. So now we're going to add 6 to each side, right? So the next step, we have 2y, because -6 plus 6 is 0. 2y equals what? -2. And therefore,
Y is -1.
y equals -1, exactly.
Okay, so I put that.
Does that make sense?
Yeah.
Okay.
Oh, I see. I see how that would work. Okay, because I put it back into the equation.
First one?
Yeah, and it should come out.
Yeah, so there's 2 negatives, so it's at minus and -6, so therefore it's +6, which
Right.
means a -4.
Exactly.
Got it.
And anytime you divide a positive, say negative by a positive, it's always negative.
That's correct. Anytime you have a multiplication or division problem that combines positive and negative, it's always a negative. Now, that assumes that we don't have another negative that's canceling it out, right? So just looking at it.
So, but
Because we could have minus 6 times minus 8 divided by minus 2, right? The negative and negative in the numerator is going to be a positive number. So then you're going to have a positive 48 over negative 2. So then the answer is negative. So you have to look very carefully. Do things sequentially until they get to be real easy for you. Because when you start getting multiple terms and lots of different, with a lot of different signs and everything, it's really easy to get confused. I promise you. I do. I have to be kind of careful with that because I tend to think about things faster than I should, which is not a bad thing per se, but nonetheless, not something that we want to repeat. So my point on this one was that even if our initial solution for one of the variables is some form of fraction, so what? It doesn't really matter. We just substitute that in, and the fraction can be complicated, like minus 8 minus 3x, all over 2. But remember, everything is over 2. Now, basically in this particular problem, when I got to y equals minus 3x over minus 2, over 2 rather, then what I should have probably done is put that minus 8 minus 3x in parentheses to make sure that we understood that is the entire term. Okay? All that making sense?
Definitely.
Okay. So let's now go down to the next page. Let's do another. Now remember, in textbooks, they will give you a set that has no solution. We saw one last class that I accidentally picked. It has no solution. So there is, you just can't randomly take in two linear equations and come up with a solution. To some extent, that's possible, although the solution may look really weird. Okay.
Like not a whole integer.
Yeah. You may have some strange fractions. You may have all sorts of answers, but they can be very weird.
Okay.
However, we cannot trust that they are consistent. They do have to have a unique solution. If they don't, then they won't have that. One example is an equation where one equation was an even multiple of another. Let's just say that you had 3x plus 2y equals 1. Well, if your second equation was 6x plus 4y equals 2, you don't have two different equations. They're the same equation. But an example of where you look at it and know immediately that it was not a consistent set would be 3x plus 2y equals 1, 6x plus 4y equal 3. Okay. All of a sudden, you double the two coefficients of the variables, and more than double the results. So that is an inconsistent equation. You can look at that and say, this can't possibly have an answer. Okay. So be aware that you can run into that sort of thing.
So the answer would be no solution.
The answer would be no solution, exactly. And there are lots of problems that you're going to run into in a lot of biology classes, maybe even a few here, that do not have a solution. So the issue of an equation, any equation is a sentence, remember? X plus Y equals Z. It's just a sentence. Some combination of X and Y can equal Z, but you have no way of determining that unless you know what the value is of one of them. And that's all we've done here, is we have found the value of one of the variables and then just gone back and substituted. Okay. There is another method of solving pairs of linear equations that we call the elimination by addition. And the place that works is we'll give a simple answer, and then we'll come back and show how this first equation could have been solved the same way. Okay, but I'm going to give you an example of an elimination by addition. That I just happen to have here. Okay. 3x plus 2y equals 1. And 5x minus 2y equals 23. Okay. Now, anytime you look at an equation, we've got one variable that each of the coefficients is the same, and they have a different sign. Okay. We can add those equations. If you look at this, let's just put down here, we'll just underline this one. Okay. If we simply add these equations together, we're going to get 3x plus 5x equals 8x. Plus 2y minus 2y is 0. And then we add, look at the other side of the equation. 23 plus 1 is 24. So now we can simply divide by 8, right? And we get x equal 3. Hi there.
Hi.
Everybody.
Good. How are you?
Good. Did you hear? Have you had mod updates yet?
No.
No. Okay. Well, I have quite a few. Can I do some
Go right ahead. I have Bernard that I'm recording the Zoom for. He couldn't be here tonight.
Okay, very good. So hopefully you can hear me. Trevor is with Joel at the moment, so just so that you know, he is on campus, but he's with Joel right now.
Okay.
So a couple of things, Monica. Good evening, everybody.
Love your shirt.
Thank you. First things first, our ACCSC visit that we had was extremely positive. They had so many wonderful things to say about our campus, and what came out of the survey the students did was number one, our students were extremely happy. It's like a 97%. And the students really do enjoy our structure. About 96 or 98%, somewhere around there. So they were super impressed with us. They were pleased at how our campus is run, how it functions, all the amazing activities we do, and they just complimented us over and over and over again. So it was a super positive. So that's good news. That makes me feel good. Yes. We have jam sessions happening. You know what jam sessions are? Just basketball. This week, all we're doing is the virtual reality escape room on Thursday. So from 5 to 6 for you guys, if you want to come do an escape room, you guys know what it is?
Yeah, I actually built
Oh, you built one.
at the outlet mall in
Oh, yes, so you know exactly what it is.
Oh.
Have you tried it yet?
Yeah.
I haven't, but I like the idea of doing it virtually, so I'm actually not really confined in a room that I can't get out of, because that'll make me panic. But to do it virtually sounds like a lot of fun. So come on Thursday if you want, and come and do that. Next week, Charles is doing Family Feud Anatomy. Now, you need to get group 3 to do that. It's some, I don't know, it sounds like throwing body parts. I don't know what that's all about. That's what it sounds like. Let's take a person apart and throw it. I don't know what you guys do. I actually don't know, because I don't want you to explain. You know, the cannibalism that goes on over there. Anyway, just a reminder, we don't have summer breaks on our campus. The reason being is your programs are accelerated. We're trying to get you to finish your degree quicker, so therefore we don't take summer work programs, but we get those degrees. So please communicate that with your families. When you guys want to, take some time off, do that function, let them know that you're still studying, you're still a student. If you happen to go to the beach, take your laptop with you, so you can at least Zoom into class, or go on Sunday, come back Monday, that's okay. So we don't break the summer. So just full content. Then who give you a care for the quarterly assembly and the luau event? That was awesome. Come on, that was super fun. Yeah. Were you here?
I didn't make it. I wasn't able to.
And then bring your family. We're going to do this once a quarter. We do our assembly. We do the needs list on our own, and we have 128 students that have got GPAs above 2.6. So that's a big chunk of our student population, so I'm super proud of them. And so we're going to try and do a big quarterly assembly where we do a function, we socialize, we do the awards. We had around between 80 and 100 people on campus that day. Were you here, Mama?
I wasn't.
It was fantastic. It was such a
I heard.
Tuesday evening, Paul is doing part math. Now, you know what math I think is.
I do.
And it's just techniques on how to lower your stress levels and so you don't feel overwhelmed. And also test your stress. So you want to test, are you stressed out right now, or are you doing okay? And some of the techniques that Paul uses will help you with that. So Tuesday, this Tuesday, next Tuesday, and next Tuesday, we're doing that. Then we have some students who have what we call lights in the tunnel, and we give them little flashlights that look like this. And that means they have 36 or less credits for their program is almost done. So if these students, they've been getting the tunnel gift. They are Guadalupe Contreras, Sarah Christopher Finkel, Lauren Johnson, Rhonda. So if you know them, let them, and David Stein graduated last year. You haven't know him? Congratulations. Wow.
David.
Good for him. Then you'll see this around lots of difference. Amanda is starting with good connection. Students from campus that they have need. So outside the Success Center, you'll see this metallic, metal, animal-like looking trough thing. And in there we want to put some personal care items, brushes, paste, whatever. Some child uses diet and wipes and so on. Maybe some cereal, some coffee, juices, cake, peanut butter, jelly, macaroni cheese, canned vegetables, canned meats, soups, things that are non-perishable, obviously. So if you have any students, we can fill up our memory and start to help those students that are really in need. Also, we have come to our attention that there are some students on campus that come to school hungry and they haven't had a meal. So in our student lounge, there's a refrigerator, and in the food section, there are frozen meals. I think if one of those students that hasn't had a meal for the day needs to eat, we don't want to hungry. Nobody can function if they're hungry. So you're welcome to go in and heat yourself up a meal and have a meal before class. Okay, so it's free for you. But please, don't bring your grocery eggs and piling stuff for your family. It's not for your family. It's for you as a student. It's your privilege. And it's something that you for us. It's come to us. You know what? We all look down on moments in our life. It happens to everybody once in a while, and it's helpful. Okay. So that's the other fun part. The fun part this evening is This week is Teacher Appreciation Week. So we'd like to appreciate the faculty and thank them for all that they do. They are amazing and they work really hard. Sundays, when you're sleeping late and having a weekend, they're grading your papers and prepping for Monday. So they work really hard, and I appreciate them. Yesterday, what's today? Wednesday. Tuesday was National Teachers Day. So, in honor of that, I would like to give Mike you a little award, a little thank you, a book and a card. Thank you so much for all that you do. You want to stand? Stand. Absolutely. I really appreciate you. Thank you for all your hard work. And yeah, we want to say thank you. And on top of that, anybody know what this means? It's Mike's birthday today. So I'm going to give him a lot of Mike, happy birthday. Please have a wonderful day. And I hope that they make your evening special and they get 100% for everything for the rest of the week. For discussions, for checkpoints, for assignments, for assessments, so on. Make it sweet and happy, okay? Happy birthday, Mike. All right, guys. That's all for me. I'm going to leave you now.
That's so cool. Happy birthday.
Thank you. Actually, interestingly enough, I was born on a Mother's Day. The night of Mother's Day.
Oh, what's the
And
name?
the snowstorm in Pueblo.
Yes. No, but how awesome is that to be born on Mother's Day? What a wonderful gift for your mom.
Yep.
Oh, my goodness.
I was
That's
her
amazing.
first child. So.
Oh, yeah. That was very special. Okay, guys. Have a nice evening, and I will see
Thank
you
you, Katie.
Thank you.
Okay. Now, okay. So, having solved for x, let's get right back to work. Right? Having solved for x, we can now solve for y. Okay, again, we can substitute it in any equation we want. So I'm just going to put it into the first equation. It's going to make it 3 times 3 plus 2y equals 1. Okay, so then we have 9, obviously. 3 times 3 is 9, right? 9 plus 2y equals 1. And what do we do next?
Move the 9 over, so negative 8. 2y equals negative 8.
So now we subtract 9 from both sides, and 2y equals minus 8. Obviously, then y
Negative.
is minus 4. And we can check this by putting it back in, right? But y is minus 4. So that is the solution by eliminating by addition as a solution. So note that that what we have in our equations is one is positive and the other is negative. But what happens if both of them are positive?
The solution?
No. If you multiply one equation by minus 1, remember it's still an equation. So now you converted that sign to a negative. Right? So, let me see if I can. I've got an example of that.
I got a question. On these, when we have problems like this, the bottom root is always when we start with.
No,
No?
doesn't have to be.
Well, I just, because like most of the problems down there always started with the bottom.
Yeah, I look at the equation and say, what's going to be easier to use?
Oh, okay.
That's all.
I didn't know if it was just
Yeah.
a method.
And it doesn't matter which one, you'll get the same answer.
Okay.
It's just that sometimes, as I say, the result might be easier to use with one of them. It's pretty obvious when you've got, say, the coefficients are, say, are 4 and 3 in one equation and 2 and 1 in the other equation. Well, obviously, you've got one that has just one, that's going to be a much quicker solution.
Okay.
So I just look at it and choose, but it doesn't matter. If you solve it correctly, you'll get the same answer. It just may be a little more complicated, and that's all, which is not terribly worrisome, right? So we can solve these that way. Let me see if I can find one here that I have to. That one I don't care for. Okay, 5x plus y equals 2. And the second equation is 10x plus 2y equals 4.
Should we do addition or?
That was not good. That doesn't have a solution. What that boils down to, this is an example where I told you that we have an even multiplier. What that boils down to is since we don't know, we only have one equation. So there are literally an infinite number of solutions to the equation. So we can't solve. Okay. That was. Okay. They're not cooperating with me very well here on this. So what I can say is that if you're given an equation where let's get rid of that. If you're given an equation where you want to use the elimination by addition, if you multiply one of the equations by minus 1, then you have a positive and a negative. Okay. So remember, multiplying both sides of the equation by the same factor still is an equation. It's not like inequalities. It's an equation. All right, makes sense? All right. So so we can always come up with a way to do this. But let's go back up to number 1 that we did, the very first equation that we did. 5x minus 6y minus 4. And 2x plus 3x plus 2y equals minus 8. Okay. Now, in this case, we don't have a simple addition, but what we have is we have a negative coefficient on one equation and a positive coefficient on the other. So what we need to, if we multiply the second equation by 3, this term becomes plus 6y. Then we have a minus 6y up here, right? So if we multiply this by 3, let's just do that. And although I don't have to put the parenthesis around the -8, it helps to be sure that we're multiplying 3 times the -8. Okay? So in that case, what we're going to get, obviously, is 9x plus 6y equals -24, right? So now if we add the first equation and our modified second equation, we get, wait a minute, yeah. If we add these, we get 14x plus 0. -6 plus 6 is 0, right? Equals -28. And if you remember, that's what we had up here after we went through a substitution. Right? It took us several steps to get there.
I see what you did there.
Yeah. So all we did,
Minus
yeah, -28, so then x equals -2. Okay. So we get the same answer. Now, obviously, we're going to get the same answer for y, because it's the correct x. So many times, if you've got an easy way to multiply an equation to have positive and negative coefficients of one of the variables and equivalent coefficients, then what you end up with is essentially a way to do this elimination by addition method. You look at, it's easy to sometimes make the choice. Obviously, in this first example that we did of the elimination by addition, we had plus 2y in one and minus 2y in the other. That made that an easy choice because, they cancel out. Right? So that's an easy choice. When it's not so easy is when those coefficients are very different. Okay? Let's, in our first one here, as I said, we've got one of them is an even multiple, but if they're not, then you're probably best off using substitution. If it's easy, you can see that it's quite easy to do the elimination by addition if we can find a way to do that, okay, and match things up.
You're looking for like factors, easy factors.
Yeah, look for the easy factors. Look at the equations and ask yourself, oh well, what's the easy way to solve this? Will both methods work? Sure, you can use substitution. As I said, sometimes the substitution might get a little cumbersome, but you can do it. That's not a big deal. But look at the system. Okay. And a little spoiler alert: you're going to see some paired equations on the in-class exercise you're going to do after the break. Okay, so we'll have some of those. Pardon?
I'm excited.
Yeah,
They're pretty easy. Okay.
yeah. They actually are pretty easy to do. Good night, Kim. Good night, Scott. So it's fairly easy, these are fairly straightforward. Don't be fooled by seeing all those numbers and letters. If they have a solution, you can find it. If they don't have a solution, you'll figure that out in a hurry. And the answer is no solution. Okay. So, so that's one method of doing it. Okay. So, questions? Okay. Right. So linear equations, we're going to, next week, we're going to get into more complicated equations. We're going to get into how do we take equations apart. And by that, I mean, how do we figure out how to simplify equations to components? This is called factoring. And a factor is something that's common to other parts of an equation, okay? Or an expression. And factoring simply looks for common elements. 6x plus 8y. What's common in those? 2. They're both even numbers. So if we divide 2 out of that, we get 2 times 3x plus 4y. So 2 is a factor. 6xy plus 8y. Okay, there's a y that's common. So 2y is also, in that case, a factor. Okay, so then it's 2y times 3x plus 4. Because remember, we're done. Remember when we were multiplying things, we talked about the distributive property. When you're multiplying, you distribute across each of the components in the parenthetical part, right? Well, this is just the reverse. We're undistributing it, basically. We're doing the reverse, pulling it back out. This is critical to solving quadratic equations, the idea of factoring. So we're going to spend some time next week. I'm talking about it now because we're going to take a break shortly, and you're going to do the in-class exercise. And if you're done with the in-class exercise quickly, then we'll introduce factoring and that sort of thing. But because we're going to go to quadratic equations next week, and quadratic equations just means that there is a variable in there that's to the second power, like x squared or y squared. Okay. And there are a couple of ways of solving those equations. Okay. One is to take it apart, literally. What can we say the two components? Because we actually multiplied a couple of those in class last week. But what can we say are the two components? And that's called factoring. And we'll talk about how that can tell us what the value of x is. Now, quadratic equations, the unknown always has two possible values. Okay. Always. So when we talk about solving these things, there's always two answers for a quadratic equation. So what we do with those is try to find out what those two values are that are a solution. If you substitute them back in, then you get an equation. Quadratic equations are useful, but they're also about, for a class like this, and for most people, will never see a quadratic equation in their professional lives. So why do we bother with it? Well, it's part of basic literacy. Okay. But more importantly, it's about thinking. It's about how we think about problems. It's about solving, coming up with solutions. And doing that is helps us then be able to tear apart other problems. Because the thought process is when we're analyzing, you're setting up a landscaping project, say. Well, you're not going to have a nice square yard. You might have a yard that looks like mine, which is kind of cornered and rounded off, and I've got all sorts of things in there, big areas where I have ash trees with big bases that are rocked in, So I've got lots of different shapes. Well, there's a problem. The problem of how do you actually figure out how to landscape that? And this weekend, we were planning to get ready for my daughter's wedding. We're landscaping our backyard. Unfortunately, I discovered I have to dig up my watering system. Yeah, that's what I was doing this morning, was digging holes in my yard to find out where the problem is. But we put in a bunch of raised beds last year. And one of them this year, we were going to put strawberries into it, but it's not a good place for strawberries. So what we're doing is planting a bunch of flowers in there, because our daughter wants it. So it's a square bed, and we wanted circles of flowers going out. And my wife was saying, how far do I have to put these apart? If my circle is this, the radius is this much. So I calculated that, calculated the circumference. Yeah. So it was a little problem solving. And it took a bit to say, well, how am I going to, oh yeah, okay. And how many of those things do you have? Ooh, okay. We'll figure it out. So we figured it out basically, and surprisingly enough, it worked. Oh yeah. Well, our tulips came up, and I nearly went out and bought a pellet gun this weekend. Bloody squirrel started decapitating my tulips. And the little bugger would climb up a tree and look and stand on a bough of the tree and eat the things in front of us. I'm sitting there, we have a great horned owl out back, and I kept saying, "Owl, lunch, come on." So what we did was what Starbucks. Starbucks will give you bags of coffee grounds. Coffee grounds are squirrel repellent. Yep. I put coffee grounds around that entire tulip bed, and the squirrel hasn't had a meal from it since. Probably saved his life.
I
tell you, last year we had a rabbit that started eating our roses. Well, I didn't care about the snapdragons because they always come back, But when he started eating the roses, and I mean, he was going to kill them when he right down. I said, rabbit's got to go. How are we going to do this? So we got some rabbit repellent. And I dumped rabbit repellent all around the roses. And looked out there, and there's the stupid rabbit standing in the rabbit repellent eating the roses.
When you have your repellent on?
I guess it did. But yeah, I was standing in the stuff, and well, so much for this rabbit repellent stuff. So I found a way to board up my yard and keep him out. Otherwise, he was going to be part of the stew, I think.
Oh yeah, there you go. We used to have little raccoons that came out to our yard and they dig up our balls every single night around 10 o'clock. And there was a family of them that had to live about a block down out in the country. And we killed them all the time. We just started shooting them, and we set up so many different traps. We had so many different contraptions. We had these little tiny bear traps once, and then we had a cat trap, and they're smart little buggers, so escape, and they're very determined to live. We only have a little 22, and it takes a lot to kill them, apparently. Yeah, and we had one that climbed up in the tree. We had to shot it so many times. It's bleeding out of its ears. Still had just life left in it. We had so many raccoons.
Yeah, raccoons can be mean too.
Yeah.
Anyway, so questions about this? Okay, so it's time for a break. My computer tells me it's 6:59. That's close enough to 7 o'clock. We'll take our 15-minute break and come back and do the in-class exercise. It'll repeat a little bit from last week because repetition is good in terms of this stuff. And I think especially for most people, including me in math, it's good to repeat. It's good to do things over and over again because it really does train you. So, well, it's like muscle memory, right? It's just a brain muscle. So it's and you know, there's an old paradigm actually that if you do something 30 times, it becomes a habit. I don't know if it's 30 or 40 or what the magic number is, but you do something enough times, and it becomes second nature. So let's take a break, and I'm going to shut off the recording on this Zoom session.